Every month, MongoDB Atlas handles 100 billion reads. Toyota streams data from millions of connected cars through it. Forbes runs every article through it. And the secret is shockingly simple. MongoDB works like a global postal network. One envelope per customer, regional sorting offices, and backup branches that never go down. Here's how it actually works. Here's the pain every junior dev has felt. You want to add one field, viral score, to your articles table. In production, with 50 million rows. That's a locked table, a migration script, and 3 teams arguing about downtime. Schema changes shouldn't feel like surgery. Now add nested data, a user with multiple addresses, a product with variants. Relational databases split that across 3 tables. Every read becomes a join. It's like mailing one letter to 3 departments and hoping they reassemble it correctly. MongoDB's fix, one BSON document holds everything. Username, nested addresses, preferences, no predefined schema. It's one envelope per customer, sealed with everything inside. Read it once, get the whole picture. No joins, no alter table, no migration meetings. Here's what nobody tells you. Adding more replicas doesn't speed up writes. Every write still goes through one primary. Secondaries only help you read faster, not write faster. Beginners assume more servers means more speed everywhere. In MongoDB, replicas scale reads. Only sharding scales writes. A replica set is your backup branch network. One primary accepts every write. Secondaries copy it by tailing the OP log, a running log of every write in order. If the hub burns down, a backup branch already has every letter logged and ready to take over. When the primary goes dark, the network votes. Secondaries notice a missing heartbeat within 10 seconds, hold an election, and promote whoever has the freshest OP log. Total failover, 15 to 30 seconds. No human paged at 3 a.m., the backup branch just takes over. MongoDB also lets you choose durability. Write concern, majority, means a write is confirmed only once most nodes have it, like requiring 2 branches to stamp your letter before calling it delivered. That's the trade-off between speed and safety. Replica sets solve reads and uptime, but every write still funnels through one primary. At millions of writes per second, that primary maxes out disk and CPU. Toyota alone streams telemetry from millions of vehicles. One post office can't sort a country's mail. The fix is sharding, splitting one giant collection across multiple replica sets called shards. A router called Mongos directs every request to the right shard. It's a country splitting into regional sorting offices, each handling its own zip codes instead of one drowning warehouse. Pick the wrong shard key and you build one overloaded sorting office. Use a timestamp and every new write piles onto the same latest shard, a hotspot. Use a hashed user ID and write spread evenly across every region. Shard key choice is the whole game. Query with the shard key and Mongo's routes straight to one shard, fast. Query without it, Mongo's asks every shard and merges results, a scatter-gather nightmare. In your next interview, say, always design queries around the shard key or one lookup becomes N. None of this works without WiredTiger, MongoDB's storage engine since 2015. Before that, MongoDB locked an entire collection just to write one document. Brutal contention. WiredTiger switched to document-level locking, letting thousands of writes happen concurrently. WiredTiger adds 3 more tricks. MVCC lets readers see a consistent snapshot while writes happen underneath them. Snappy compression shrinks storage 60 to 80%. And a write-ahead journal checkpoints every 60 seconds, so a crash never loses more than a minute. Here's the Postal analogy's final piece. WiredTiger keeps hot documents in memory, half your RAM by default, like a clerk keeping the most requested forms within arm's reach. Popular reads never touch disk. That's why most of those 100 billion reads finish in under a millisecond. Need business logic, not just lookups? MongoDB's aggregation pipeline runs multi-stage transformations directly on the server, filter, group, sort, without pulling raw data across the network. Think of it as bundling mail into reports before it leaves the post office. On a sharded cluster, that pipeline doesn't run in one place. Each shard runs its own slice in parallel, then Mongo's merges the partial results. Its regional offices each tallying their own totals, then one clerk adding them up at headquarters. Want full-text search with typo tolerance? Most teams bolt on a separate Elasticsearch cluster. More infra, more sync headaches, more 3 a.m. pages. Atlas Search embeds Apache Lucene directly inside MongoDB. One database, one query language, fuzzy matching built in. Need real-time updates instead of polling? Change streams tap directly into the op log and push every insert, update, or delete to your app instantly. It's a mail carrier texting you the moment your package ships, not you calling the post office hourly. Forbes runs its entire content platform on this model. Every article is one document: text, author info, tags, related links, all embedded together. Want an AI summary field tomorrow? Just write it. No migration, no downtime, no tickets. Toyota's connected vehicle platform ingests telemetry from millions of cars: location, diagnostics, driver behavior, all wildly different shapes per model. Atlas auto-scales shards to absorb traffic spikes, and documents absorb messy sensor data without a rigid schema fighting back. Zoom out and the numbers are staggering. Sub-millisecond reads from memory cache, 60 to 80% storage savings from compression, and automatic failover in under 30 seconds. This is what lets one platform serve a two-person startup and Toyota's global fleet. In your next system design interview, say exactly this. MongoDB scales reads with replica sets, scales writes with sharding, and picks a high cardinality shard key to avoid hotspots. That sentence proves you understand trade-offs, not marketing copy. Zoom all the way out, and MongoDB is the postal network. Mongo's is the sorting hub. Shards are regional offices, replica sets are backup branches with an oplog record, and WiredTiger's cache is the clerk keeping popular forms up front. Adobe and Verizon run similar workloads. Massive, varied, fast-changing data that would drown a rigid schema. The pattern repeats everywhere. Flexible documents up front, horizontal scale under the hood, hot data one memory lookup away. MongoDB estimates roughly 80% of modern applications have hierarchical, evolving data, user profiles, product catalogs, content platforms. That's the real reason document databases exploded. Most software was never a perfect fit for rigid rows and columns. But don't over-embed. Cram unlimited comments into one document and you hit MongoDB's 16 megabyte document limit and slow, bloated reads. The senior move is knowing when to embed and when to reference, like knowing when one envelope needs a second package. 6 ideas carry this entire architecture: documents instead of tables, replica sets for uptime, sharding for write scale, WiredTiger for speed, aggregation for server-side logic, and change streams for real-time updates. Master these, and you can explain MongoDB at a senior level. 100 billion reads a month, 39,000 plus paying customers, Toyota's entire connected fleet, Forbes' entire newsroom, all running on the same 6 ideas you just learned. Dressed up as a very well-engineered postal service. MongoDB isn't magic, it's a postal network. One envelope per customer, regional offices for writes, backup branches for uptime, a clerk keeping popular forms up front. Explain it that way in your next interview, and you'll sound like you built one. Subscribe for the next deep dive.